In section 2.7, we're going to talk some more about functions and some different things that can be done with functions, even and odd functions, piecewise functions, some different things with functions. But first, I thought we might need to have a little chat about just what the term function means. We've been using it, but we kind of need to give a little more clarification to what that term means. So remember that we've said before that y means f of x. Anytime we see f of x, we could replace it with y. And that's true, but if they mean the same thing, then why do we have both terms? Why do we say y and f of x? Why don't we just have one of those terms, like y, and that would be enough? And the reason that we need both of them is that not all equations are going to produce a function when you graph them. For instance, y equals 5x plus 4, that's going to be a line. Y equals x squared plus 3, that's going to be a parabola shifted up 3 units. Y equals absolute value of x minus 4, that's going to be the V shape moved to the right 4 units. Okay? And in each of these cases, we could replace y with f of x, and that would be fine. These are all functions. But sometimes when you have a y in equation, it's not a function. For instance, if I said x squared plus y squared equals 9, that's actually not a function. We'll talk about y in a second. So in this particular case, it would not be appropriate for me to trade out the y with an f of x, because this one's not a function. We only use f of x when it for sure is a function. Okay, so how do you know whether or not it's a function? Well, a function will pass what we call the vertical line test. And what that means is if we hold our pencil vertical to a graph, so in other words, there's a graph of a parabola right here. If I hold my pencil vertical to the graph, I hold it parallel to the y-axis here, and I drag my pencil across, I never touch more than one point at a time. So right now I'm touching this point. If I scoot it over a little bit, I'd be touching this point. If I scoot it over a little bit, I'm touching this point. But I never have 2 points directly above each other that I'm touching at the same time. So this one right here is a function. And notice that it's that parabola shape, it's got an x squared in its equation. So that's why when we have x squared, it's like this one, y equals x squared plus 3, it is a function. Okay? Now, this picture over here is a circle. And if I take my pencil and I drag across vertically here, if you'll notice this spot right here, my pencil is touching 2 points at the same time. The ordered pair of this point is like 0, 8, I think, because it looks like they're counting by 2s. And this point is at 0, negative 2. So 2 different points when x is 0, there's 2 different places that function or that graph exists, which means it is not a function. The vertical line test says that if you drag your pencil across vertically, you will never touch more than 1 point at a time. Okay? You'll never touch more than 1 point at a time. Another way of saying that is there are no points that are stacked up on top of each other. Here, these 2 points were stacked up on top of each other, so this graph is not a function. We never had points directly on top of each other. This one is scooted over a little bit. So there are never points directly on top of each other, so it's a function. Another way to say it is that if you have a function, the x's do not repeat. Okay, the x's do not repeat. The x's are all different. So right here on this one that was not a function, do you see how we had a repeat of 0? 0, 8, 0, negative 2. There's a repeat in the x's, so it was not a function. Every point over here had a different x value, so it is a function. Okay? So, why do we use f of x for functions and y when they're not functions? Well, here's the deal. When we use f of x, we are making a promise that when you graph it, it will be a function. F of x comes with that promise. It's saying, hey, I promise this is a function. The x's are all going to be different. There will not be a repeat in the x's. Okay? So in this equation right here, they had to use y. Okay? If they had used f of x, they would be making a promise that wasn't true. So they had to use y. By the way, when you have an x squared and a y squared in this format right here, this picture right here would be a circle. And that's what produces these circle equations, is this x squared plus y squared equals a number format. Okay? All right, so we've looked at a couple of pictures and decided whether or not they're functions. let's look at a couple of sets of ordered pairs, okay? So here's a set of ordered pairs. The first point in the set of ordered pairs is 2, 3. The next one is negative 2, 4, 0, 4, and 2, negative 5. So does this set of ordered pairs represent a function? In other words, if we graph it, would there be points on top of each other, or would they all be different x's? And if we look through, see how there is a repeat in the x's. So if I made a graph, the point 2, 3 and the point 2, negative 5 would be on top of each other. That means this set of ordered pairs is not a function. There is a repeat in the x's. Okay? This is what we call this is called just a table. So we can look and see that if we plotted the points, negative 3, 0 would be a point, 0, 1 would be a point, 3, 2, 6, 2, and 9, 3. So if we look at our x's, all of these x's are different. So yes, this is going to be a function. The x's are all different. Now some people say, hey, look, Beck, there's a repeat in your y's over here. There's a repeat in the 2's. Doesn't matter. We don't care. The problem is x's. If x's repeat, then we're not dealing with a function. But if you plotted these points right here, 3, 2, and 6, 2, they are not on top of each other. We're still good. So the issue that we're looking for is a repeat in the x's. Okay? Then they ask us to sketch a couple more that are functions and a couple that are not, and let's classify. So you can kind of draw what you want. As we go further in the course, we're going to see some really crazy graphs that may look something like this. But if you'll notice that on my drawing here, if I drag my pencil across vertically, I never touch more than one point at a time. So this is a function. Now where you run into problems is if you were to have it loop sideways. Maybe I went back like that. Now I've got points stacked up on top of each other. Now it's not a function. Do you see the difference? Okay. If you have points that stack on top of each other, it's not a function. Another way to do that is maybe a up and down parabola is fine. But if you have a sideways parabola, that's not a function. Okay. Another type of graph we'll see a little bit later is our rational functions. We talked about this very briefly in 2.6. Where the graph kind of zooms up on one side or kind of levels off on the other maybe. If you'll notice, if I drag my pencil across vertically, I'm never touching more than one point at a time. So we're good. This is a function. That one is a function. Horizontal lines are a function. But notice, vertical lines are not a function because those points are on top of each other. So hopefully you could look at a graph and decide whether or not it's a function. If it is a function, then it's appropriate to use f of x instead of y. If it's not a function, then we can't use f of x. You have to stick with y. Okay? All right, something else that happens in our functions is some functions, not all, but some functions can be classified as even and some can be classified as odd. Okay? So briefly, here's what it means to be an even function. If it's an even function, it will be symmetric with respect to the y-axis. In other words, if I folded the graph over on the y-axis, the two sides would match up. Here's an example of an even function. If I folded it over the y-axis, if I was a perfect artist, do you see how this part would match up with this part? Okay, so that would be an even function. Notice the equation for that, or the function. The equation would be y equals x squared, or f of x equals x squared. Okay, so that's an even function. I remember e and y, even y-axis. If it's an even function, it can fold over the y-axis. Okay. Now another way to think about that: if our original function is f of x, okay, and then we found f of negative x. Now remember from our transformations that if you put the negative in parentheses with the x, that causes it to flip sideways. So notice that here's my original f of x, but if I graphed f of negative x, if I took and flipped it over the y-axis, the two sides would match up. So f of x and f of negative x would be the same picture. It would give us the exact same graph. Okay? So if f of x equals f of negative x, then you know you're dealing with an even function. Okay, odd functions. Odd functions are symmetric with respect to the origin. I remember it this way. O's go together. O for odd, O for origin. Odds are symmetric over the origin. Let me give you an example of an odd function. Y equals x to the third, or f of x equals x to the third. Remember, when we have an x to the third power, the graph looks like this. Okay? If I were to take and anchor this graph down at the origin and twist my paper 180 degrees, do you notice that it looks exactly the same? It's still going up on the right, down on the left. If I turn this paper 180 degrees around the origin, it looks exactly like it did before. Okay? That means it's symmetric around the origin, and it's an odd function. Okay? Another way to check that algebraically is to say, okay, well, what is f of negative x? Now remember, f of negative x flips it over the y-axis. So f of negative x would cause this part to flip up this way, and this part to flip over this way. Well, that doesn't match the original, but then notice I say, okay, well, negative f of x. Remember, if we put the negative outside the x, it's going to cause it to flip vertically. So this top part would come down, and this bottom part would flip up. So notice what just happened. When I flipped this graph horizontally, it looks exactly the same as if I flipped this graph vertically. So f of negative x looks exactly the same as negative f of x. Okay? And that's exactly what it means to be an odd function. Okay? That f of negative x looks the same as negative f of x. That it looks like it's symmetric around the origin. Okay? All right, so let's look at a few graphs and see if we can decide by looking at the graph whether the function is odd, even, or sometimes neither one. Okay? Sometimes functions are not odd or even. They're just random functions. Okay? All right, so I bet you can tell that this one is the absolute value function. I bet the equation was y equals absolute value of x. Or you could call it f of x equals absolute value of x. That's the same thing. Okay? And let's see, is it symmetric over the y-axis? Sure is. If I flipped it horizontally, it would be symmetric over the y-axis. So this is an even function. Okay? All right. Second one here. Well, if I flip it over the y-axis, I flipped it over, this part would come over here. It does not, that's not the same picture. If I flipped it over, it's in a different location here. So it's not even. And if I rotated it 180 degrees around the origin, if I anchored my pencil right here at the origin and twisted it 180 degrees, the parabola would be in the bottom left-hand corner. Okay, which does not match the original. So this one is not even, but it's also not odd. It is neither one. Okay, it's not even or odd. Okay, this picture. Well, if I flipped it across the y-axis, this part would come over here and this part would come over here. That's not what the graph looks like. But if I rotated this picture 180 degrees around the origin, it looks exactly the same, doesn't it? So this is an odd function. It's rotated. If you twisted it 180 degrees, it would look exactly like it does now. Okay? All right, bottom left-hand corner. Notice if I flip it over the y-axis, this part would match up to this one. So it's even. And this one, I apologize, I don't know why that little straight line got cut through. Pretend that's not there. It's not supposed to be there. This one's not even. If I flipped it across the y-axis, it would be going up forever on the right here. When I flipped it over, it would be going up forever on the left. That's not the same picture. Okay, so it's not even. But if I anchored it right here at the origin and twisted it 180 degrees, it would be the same picture. See how this part's going up on the right? When I flip it 180, it'd be going down on the left. The little valley in the lower right corner, if I twisted it 180, would be a peak in the upper left. So this is an odd function. Okay? All right, we'll look at some algebraic information with even and odds in the next video.